So this is part 3 of atomic theory. This is looking at electrons in atoms, and we're going to look at the noble gas electron configuration. In part 2 we just looked at electron configuration and how do you figure out the electron configuration. This time we're going to convert those into noble gas, which oftentimes is more useful because it's less to write, and oftentimes periodic tables only have the noble gas electron configuration because it takes up less space to write it. So knowing this is going to be valuable. So let's talk about titanium. If you viewed part 2 of this series of videos and looking at electron configuration, you know we looked at titanium and figured out what is the electron configuration for titanium, and this is what we came up with. Now if you totaled up all the electrons that you see here, it would add up to 22 electrons, and so that's how we worked our way through. Now, the real focus of all this is trying to understand valence electrons, because once you understand valence electrons, or the electrons that exist in the outermost energy orbital, then you can start to figure out how they bond together. So why do different elements bond together, and why do two hydrogens hook themselves to one oxygen, and you'll then be able to figure out what type of bonds happen. So very soon here we're going to move into ionic bonding and covalent bonding, and understanding all of this thoroughly will help you when we get to those sections. So what we need to understand for valence electrons is what the outermost electrons are. We don't care about any of the ones in the center, just the very outer edge ones, because those are the ones that determine bonding. When we look on the periodic table over on the far right hand side as you're looking at it, these ones over here are called the noble gases. They're called the noble gases because their electron configuration is completely stable. They don't have to share electrons or steal or give away electrons ever. They're perfectly happy. So they're called noble gases because back in the old days, nobility never mingled with anybody else out here on the periodic table. So this noble gas configuration, we're going to end up using these ones over here to write this out. Understanding that those are the only noble gases is going to help you out. Now, if we go back to titanium with 22 electrons, again, this is the electron configuration that we came up with. We've got 22 electrons accounted for. To write the noble gas configuration for that, we have to go back to our periodic table. Back to our periodic table. And we find titanium again. So titanium is right here, number 22. And we work our way backwards in number, so decreasing, and we have to go back up until we reach the next closest noble gas, and in this case that's argon, and argon has 18 electrons. Okay, so we'll remember the next closest noble gas, working our way backwards, was argon. So if we bring this back up and look at the electron configuration, we can see that right here we've got 2, 4, and 6 more is 10, and 2 more is 12, and 6 more is 18, which leaves us with the configuration for argon. So we don't have to write all that out if we're doing noble gas configuration. All we have to do is put some brackets, write AR for argon, because this is the electron configuration for argon, and then put whatever is left over. And really what it means is these things that are left over are unfilled energy levels, and that's going to be important for figuring out valence electrons. But you can do this with any of them to figure out the noble gas configuration, and in the next section we'll figure out we've got these two electrons that are all by themselves. So what do we do once we know the valence electrons? Okay, another example might be sodium. Sodium is number 11 on the periodic table. If we're going to do electron configuration for sodium, we need to work our way backwards and find the next closest noble gas, which takes us to neon. Neon has 10 electrons. Now if we come down here and look at the configuration of sodium, which is down here, we've got 2, 4, and 6. That's 10 electrons. So that must be the configuration of neon. We can write that out as Ne and then whatever's left over, 3s1. We've got the third energy level, S shape, 1 electron, and if we were trying to figure out valence electrons, we now know that this is how many valence electrons we have. And in the case of sodium, we have 1. So this is noble gas configuration. In the next section, we'll look at Lewis dot structures, also called electron dot structures. So look for activity or part 4.